Hello everyone, my name is Mr. Ajimai and I welcome you to our second mathematics lesson. In our previous lesson, we learnt about the Pythagoras Theorem, meaning that we are going to learn more about the Pythagoras Theorem. In our previous lesson, we learned that the Pythagoras Theorem states that the sum of the squares of the opposite and the adjacent of a right-angled triangle is equal to the square of the hypotenuse. Thus, we have a diagram here. A, B, and C are used to represent the adjacent, the opposite, and the hypotenuse of a right-angled triangle. Thus, we have A squared plus B squared is equal to C squared. We have an example here from our previous lesson, where the opposite and adjacent are represented by 12 centimeters and 5 centimeters, whereas the hypotenuse is represented by h. We are then expected to find the value of the hypotenuse, which is h. And in our example, we learned that by using the Pythagoras theorem, we have a squared plus b squared is equal to h squared. Our a is going to be 12 centimeters, which is going to be 12 squared, plus the b, which is 5 centimeters, is going to be 5 squared is equal to h squared. 12 squared is the same as 12 times 12, plus b squared is the same as 5 squared is the same as 5 times 5, and we are supposed to get h squared. 12 times 12 is equivalent to 144, plus 5 times 5 is equivalent to 25, which is the same as h squared. 144 plus 25 is like this. 144 plus 25 is supposed to give us 4 plus 5 is the same as 9. 4 plus 2 will give us 6. Then here is 1. So we have 144 plus 25 will give us 169, which should be equal to what? H squared. Making the h our subject of the formula, we can rewrite this as h squared is equal to 169. And in maths, from last week, we learned that anytime a square moves over an equal sign, changes into a square root. So to make h the subject of the formula, we are going to have h is equal to the square root of 169. Therefore, h is equal to 13 centimeters. If you remember, in our last lesson, I told you that in our next lesson, we're going to learn about how to find the adjacent and the opposite. So I told you that peradventure you've been given the hypotenuse and the opposite. How are you going to find the adjacent? Or you've been given the adjacent and the hypotenuse. How are you going to find the opposite? Today, I have two examples here to illustrate this. In this first lesson, we are going to learn how to find the opposite. So, using the Pythagoras theorem, we are going to have a squared plus b squared is going to give us c squared, and the value of our a, which is the opposite, is 8 centimeters. So we are going to have a squared plus the value of the b, which is the adjacent, we don't know, so we're going to have b squared plus it's going to give us equal to the hypotenuse, which is c squared, is going to be 10 squared. So we have 8 times 8 to give us 64, plus b squared is going to give us 10 times 10 is going to give us 100. We have to make b squared the subject of our formula. So we have b squared is equal to 100 minus 64. If you remember, in your lessons, you've been told that anytime addition moves over an equal sign, changes to subtraction. So 64 plus 64 moving over an equal sign will become minus 64. So we have b squared is equals to 100 minus 64. B squared is going to give us 100 minus 64. 4 minus 0 is not possible, so we borrow 1 from here. Here will become 10, and here will become 9, and here is nothing. So we have 10 minus 4 is 6, then 9 minus 6 is what? 3. We therefore have b squared is equal to 36. And we just learned that anytime a square moves over an equal sign, changes into square root. So in making b the subject of the formula, we are going to have b is equal to the square root of 36. And the square root of 36 is equal to what? 6 centimeters. Therefore, the solution for this first example is like this. We are now going to solve our second example, where we've been provided with the hypotenuse and the opposite. So let's say from our formula we said that a squared plus b squared is going to give us what? C squared. And the a we don't know, so we are going to have a squared is equal to b squared. A squared plus what? 12 squared is going to give us 20 squared. We have a squared plus 12 squared is going to give us 144. Is going to give us equal to 20 squared is what? 400. In making a the subject of a squared the subject of the formula, we are going to have a squared is equal to what? 400 minus 144, because we just learned that anytime addition moves over an equal sign, it becomes negative. So this positive 144 moving over to this side is going to become negative 144. So a squared is equal to 400 minus 144. And in solving this, 4 cannot be subtracted from 0, so it's going to be 10. It's going to change to 10 because we borrow 1 from here, and here will be 9, and here will become 3. So we have 10 minus 4 is going to give us 6. 9 minus 4 is going to give us 5. And then 3 minus 1 is going to give us 2. We have a squared is going to give us 256. To make a the subject of the formula, we have to move this square over the equal sign and to become a square root. So we have a is equal to what? The square root of 256. And from our previous lesson, we learned that the square root of 256 is equal to 16. So we have the square root of 256 being 16 squared. 16 centimeters. So a is equal to 16 centimeters. Therefore, this is the solution for example 2. Example 2 is this, and this is the solution. I hope you all enjoyed today's lesson. I'm now going to give you exercises to solve on your own at home. Thank you very much, and have a wonderful day.